Hello Internet, Zach here, and welcome back to Collecting the Elements. In the first episode since I finished the lighting upgrade, I'm going to be adding an element that took me almost a year and a half to isolate. It's element number 25, manganese. That's not manganese, those are manganese. No, I meant manganese. A hard, brittle, silvery gray metal that can be added to steel alloys to improve their tensile strength, or added to aluminum alloys to improve corrosion resistance. Its compounds have a myriad of uses, from manganese dioxide in carbon-zinc batteries, to manganese carbonate, which is used in pottery and glass making as a pigment, to potassium permanganate, which is a powerful oxidizer that can be used as a stain for microscopy, or as a disinfectant. In biology, manganese occurs in, well, too many proteins to list. That's why it's an essential nutrient for most known life forms on Earth. So I'll be isolating manganese from some pottery-grade manganese carbonate that I picked up at Georgie's Ceramics. The trouble is, pottery grade isn't technical grade. And what was foiling my efforts for the past year and a half was these impurities. So the method I'm going to show you eliminates the impurities and makes it possible to actually extract the metals. So let me show you how I did that. So this is the last of the manganese carbonate that I picked up at Georgie's Ceramics. And I'm going to run under the assumption that this is actually impure. Let's get all that into a jar here. And I'm going to add to it some hydrochloric acid. So I haven't gotten all of the carbonate to dissolve yet, but at this stage I have enough dissolved to know that this isn't the pretty pastel pink that pure manganese chloride is supposed to be. So to purify the manganese, I'm going to be using the selective hydroxide precipitation process. So here I have a solution of sodium hydroxide, and I'm going to add this to the impure manganese chloride and stir until I've precipitated all of the metals out as hydroxides. And now I'm going to allow this to settle for a while. Yes, this is an actual broken coffee maker that I'm using as a filter holder. And these are my hydroxides. And I'm just going to start pouring these through the filter. Dissolving the rest of the manganese carbonate has not only not resulted in a pink solution, but has resulted in a dark brownish-red solution. I've finished filtering the hydroxides, and the surface layer of them has oxidized quite a bit in the air. The layer underneath is still pale. So I'm going to rinse this with some more distilled water. The point is to rinse out all of the sodium ions that are sticking around in here. I've transferred the crude manganese chloride to a bigger container. And I'm going to start scooping up some of these hydroxides out of the coffee filter and mixing them in. After doing the selective hydroxide precipitation, the solution is finally the proper pale pink color of manganese. So now I'm going to pour this into the saucepan of science and boil it down to try to make manganese chloride crystals. This is the kind of cold, windy weather where even at full power, this is all the boiling that's happening. It's kind of sad. So I'm finally starting to see the beginnings of some kind of crystal growth over here. So hopefully this will make nice manganese chloride crystals. Hopefully. So I shut the heat off. I'm going to let this cool down slowly and hope for the best. I am a little concerned that this is looking like yellow instead of pink. And the solution almost looks green. So the manganese chloride has cooled and crystallized and is kind of yellow. Now, that looks to me a lot like contamination with iron 3 chloride. So out of curiosity, I put some in acetone. And that definitely looks like iron 3 chloride coming off in the acetone. So I'm going to scoop the rest of the crystals in here, and I'm going to wash them with acetone to get the iron contamination out. Stir this up, break up the chunks. After the first washing with acetone, the acetone has turned the bright yellow of iron 3 chloride. So I'm going to pour this off. And I'm going to give this another rinse. Looking a little better. This time it's not rapidly turning yellow. It's a little yellow, but it's not intensely yellow. So we're getting a lot closer to being iron-free. Some of the manganese chloride is still suspended, but it's not too huge a loss. This here is nice, pale pink. This is what manganese chloride is supposed to look like. So I tried to set the manganese chloride out yesterday to let the residual acetone evaporate off. And then it decided to rain. So it's all clumped up into these hydrated manganese chloride chunks. I'm going to dissolve all of this manganese chloride in water. Alright, most of the manganese chloride has dissolved in here. So I have a little dish full of mineral oil right here. I'm just going to take a couple of drops of the saturated manganese chloride and put them into the dish. Here's a sample with much smaller drops dyed green. Here I have a solution of sodium bicarbonate that I'm going to be adding to the purified manganese chloride to convert it into manganese carbonate. And I'll just keep adding sodium bicarbonate until the fizzing stops. And at that point I'll know that all of the manganese chloride has been converted into the carbonate. Now that it's reacted, I'm going to top this off with distilled water. This will help dissolve any unreacted sodium bicarbonate and any sodium chloride created as a byproduct. So I'm just going to stir this up and I'm going to let it settle. And when all of the manganese carbonate is settled out, I'll decant off the solution on top. Manganese carbonate twice and poured it off into a smaller container. Notice this looks nothing like the pale tan colored powder that I poured out of the bag earlier. So the next step is to convert the manganese carbonate into manganese oxide by heating it up. That looks about right. Nice, dark manganese oxide. I need 1.84 grams of aluminum powder. Here I have a measuring cup full of pottery grog, which is basically finely ground ceramic. And that'll resist the heat of the thermite reaction. And I've made a little depression here to put the thermite mixture into. I'm hoping that by compressing it down, I can help it burn a little better. Little piece of grog on top of that to trap the heat in and keep the oxygen out. Let's see what's under here. Well, whatever this is solid. Okay, it's a little bit brittle. But what is that? It's a weakly magnetic flake of metal. Gonna sit that in there. Thing is, I think I see pieces of metal in here. Wait, what's that? Oh! That's manganese metal. So after digging through the slag, picking up all the pieces I can, I have a couple of decent sized chunks of manganese metal here. This one has a couple of shiny surfaces where it broke apart. And I have everything from small chunks down to flakes down to crumbs of metal. This is another nice shiny piece. So, it's time to put these in a glass vial and seal them off. So after nearly a year and a half of fighting with it, this is manganese, the 39th element added to my table. So I hope you all enjoyed this. If you did, hit the like button. If you want to see more, hit subscribe. If you know someone else who would enjoy this, hit share. And if you can, throw me a few coins on Patreon or PayPal to help me make more videos. Anyway, see you next time.